Hi YouTube people, I'm teacher Regy Safadão and today we're talking about the thermal expansion of liquids. Are you ready? So, come with me! Hi YouTube friends, I'm your teacher Regy Safadão and this is our class number 5 of 6. See our opening. As we already know, this is our channel of Mathematics Without Frontiers. And here we have classes of physics, mathematics and English in two versions. One version in English and the other one in Portuguese. Go there and visit us. Our video classes in Portuguese are excellent, all right? Well, today, our class is about thermology, thermal expansion of liquids. Well, before starting solving our 4 exercises of today, we have to remember the 2 important points I meant. One very important point is that liquids expand much more than solids. So, when you have a container full of any kind of liquid, and there is a change in temperature, of course, this liquid will overflow. Okay, it is important to know. All right, so let's start our first question. Just pay attention. Question number 1. A 300 cubic centimeter glass is filled to the brim with alcohol at 10 degrees Celsius. Calculate the volume of alcohol that will overflow when the glass is heated up to 9 degrees Celsius. Gamma of glass is 27 times 10 to minus 6 per degree Celsius. And gamma of alcohol is 1,100 times 10 to minus 6 per degree Celsius. All right, so this is just an illustrative picture. And what is given in our problem? Gamma of glass, gamma of alcohol, VI, TI, and TF, all right? Well, we can solve this very easily and also very fast. What is required? Delta V overflow, all right? So let's calculate the change in temperature. It is always the final temperature minus the initial temperature. And then we are going to calculate the gamma that overflow. And finally, the delta V that overflow. Okay, so calculating the delta T, we have delta T is 90 minus 10. So the change in temperature is 80 Celsius degrees. Now, let's calculate the gamma overflow. All right, so it is plugging the values into the formula. We have that gamma of alcohol minus gamma of glass is gamma of alcohol, 1,100 times 10 to minus 6 minus 27 times 10 to minus 6. Okay, so you can see that, okay, here we have laser. So 1,100 is in green and 27 is also in green. Why? Why I wrote them in green in a different color? Because I'm going to operate them only. Okay, so now I'm going to operate 1,100 minus 27. So gamma overflow is 1,073 times 10 to minus 6 per degree Celsius. Okay, now we are going to plug those values, okay, delta T and gamma overflow here in this formula. All right, and now we can calculate delta V that overflow easily. Let's see. Plug in the values, and also I wrote the values. I'm going to multiply right now in green. You can see 1,073 times 300 times 80. Okay, let's do this multiplication. So delta V overflow is 25,007,500. Okay, times 10 to minus 6. Well, now I'm going to multiply this number per 10 to minus 6. What it means? It means that I'm going to move the decimal point 6 units to the left, okay? 6 units to the left, because here we have minus 6, okay? I have a negative 6, all right? So the decimal point is right here. So count with me, 6 units to the left. Let's count. 1, 2, 3, 4, 5, 6. So the decimal point is going to be here. So we have that delta V overflow is about 25.75 cubic centimeters. Okay, so this is the amount of liquid that is going to overflow. Okay, so let's see question number 2. So far so good. Let's go there. Come on. Question number 2 is 650 liters bus tank is completely filled with fuel at 20 degrees Celsius. Supposing this bus parked under the sun in a warm day, find the amount of fuel that overflows when the tank is heated up to 65 degrees Celsius. Volume expansion coefficient of steel is 42 times 10 to minus 6 per degree Celsius. And the volume expansion coefficient of fuel is 950 times 10 to minus 6 per degrees Celsius. So also another illustrative picture. And what was given? Gamma of fuel, gamma of steel, VI, TI, and TF. As I told you before, what is required? Delta V overflow again. Okay, so delta T, the change in temperature, final minus initial. Okay, gamma that overflow. And also, let me move my window from here. All right. Okay, so let's start by finding the delta T. All right, so the change in temperature is 65 minus 20. So delta T is 45 Celsius degrees. Now, let's find the gamma that overflow. Well, so gamma of fuel minus gamma of steel. So 95 times 10 to minus 6 minus 42 times 10 to minus 6, okay? Well, you can see that is in yellow color. Why? Because I'm going to operate only them now. So 950 minus 42. So our gamma that overflow is 908 times 10 to minus 6 per degree Celsius. Now we can plug these values, gamma and the delta T, into this formula and also VI, okay? So plugging these values into that formula, we have that delta V that overflow is 980 times 10 to minus 6 times 650 times 45. Okay, you can see the color. It is in a different color in order to make you see, not to make you understand it better. Okay, so 908 times 650 times 45. Okay, so it gives us that delta V overflow is 26,559,000 times 10 to minus 6. Now I'm going to multiply this number by 10 to minus 6. What it means? It means that we are going to move the decimal point 6 units to the left. Okay, let's count. Please count with me. Now, 1, 2, 3, 4, 5, 6. So the decimal point is going to be right here. It means that delta V overflow is about 26.56 liters. All right. So this is the amount of liquid that is going to overflow. All right. Let's go to question number 3. So far, so good. So let's go there. It's here already. An aluminum pan has a capacity of 5 liters and it was filled to the brim with water at 25 degrees Celsius. It is known that the volume expansion coefficients of water and aluminum are 130 times 10 to minus 6 per degree Celsius and 66 times 10 to minus 6 per degree Celsius, respectively. Determine the amount of water that overflows at 150 degrees Celsius. Another illustrative picture. And what was given? Gamma of aluminum, gamma of water, VI, TI, and TF. So what is required? Again, delta V overflow. Let's see, delta T, gamma overflow, and also delta V overflow. Well, let's find the change in temperature. So delta T is 150 minus 20 5. So it gives us that delta T is 125 Celsius degrees. And now let's find gamma overflow. It is 130 times 10 to minus 6 minus 66 times 10 to minus 6. Well, it is also in a different color. It is in red. You can see 130 and 66. Why? Because I'm going to operate only them right now. So 130 minus 66 is 64. All right, so gamma is 64 times 10 to minus 6 per degrees Celsius. Now we can plug these values, gamma and delta T, and also VI, okay, 5 liters. We can plug these values into the formula. All right, so delta V overflow is 64 times 10 to minus 6 times 5 times 125. It is also in red because I'm going to multiply only them right now. So please, 64 times 5 times 125 is 40,000. Okay, so now 40,000 times 10 to minus 6 means that I'm going to move the decimal point 6 units to the left. All right, please count with me here. 1, 2, 3, 4, 5. I need to move one more to the left. Okay, so 5, stop here, 5, and then only one more, 6. So the point's going to be reading right here. So the delta V overflow is about 0.04 liters. This is the amount of liquid of water that is going to overflow from the container. All right, so please, let's go to question number 4. This is our last one. So question number 4 is already here. A 500-liter plastic container is completely filled with liquid at 24 degrees Celsius. It is known that 30 liters of this liquid overflows when it is heated up to 9 degrees Celsius. Find the liquid real expansion coefficient. So alpha of plastic is 5 times 10 to minus 4 per degrees Celsius. Well, this question is a little bit different. Let's see what was given. VI, delta V overflow was given now. I don't want to calculate it, okay? So this question is a little bit different from those 3 ones before. TI is 24, TF is 90, and alpha of plastic, all right? We have to convert from alpha into gamma, okay? Okay, required is gamma real. Okay, so gamma of plastic is 3 times alpha of plastic. Alpha is 5 times 10 to minus 4, so 3 times 5 is 15. Okay, we can see here. Alpha of plastic is 5 times 10 to minus 4, and 3 times 5 is 15. So gamma of plastic is 15 times 10 to minus 4 per degrees Celsius. See, I'm not going to use alpha. The program gave me alpha and I converted this alpha into gamma. I'm going to use gamma. I'm going to apply gamma. All right. So delta T is TF minus TI, and delta overflow, that V, that overflow is gamma overflow times VI times delta T. And gamma real is gamma overflow plus gamma of plastic. So delta T is 90 minus 24, so it is 66 Celsius degrees. Well, gamma overflow, it was given, so delta V overflow is 30, it was given. Gamma overflow is here, I'm intending to calculate this. VI was given, it's 500. Delta T is 66, I calculated down here, okay? So it is in blue because I'm going to multiply this right now. So 500 times 66 is 33,000, okay? Very good. Now, this value is multiplying, so I'm going to move this value to the first member of the equation, dividing, okay? And what I did a kind of rotation, okay? Because I want this variable on the left of my equation. So gamma overflow is 30 divided by 33,000. All right. So I can show you again. Okay, you can see it is. So gamma that overflow is 0.000909. Okay. Now, see what I'm going to do. I'm going to change this decimal number, okay, to convert this decimal number into a scientific notation, okay? So it means that this part of the number, okay, needs to be a number greater than or equal to 1, but less than 10, okay? And this is a base of 10, okay? So see, if this part of the number needs to be a number greater than or equal to 1, but less than 10, so I'm going to write the decimal, the decimal point right here, isn't it? Yeah. So count with me how many units I have here on the left. 1, 2, 3, 4. Okay. So if I want to write the decimal point right here, as I did here, 9.09, I have to write 10 to minus 4, okay? So this is the value written in scientific notation, okay? So gamma that overflow is 90.09 times 10 to minus 4 per degree Celsius. This is just the unit of the gamma, okay? Well, now let's finish. So gamma real is 9.09 times 10 to minus 4 plus 15 times 10 to minus 4. So gamma of plastic was given at the beginning of our problem, okay? In fact, it was not given. It was given alpha of plastic. I converted, okay? So now let's operate. 9.09 plus 15 is 24.09, okay, times 10 to minus 4, okay? But remember what I told you? This part of the scientific notation cannot be 24, okay? Because remember I told you this part of the scientific notation needs to be a number greater than or equal to 1, but less than 10. Okay, so this point, this decimal point needs to be written here. I have to have 2.4. Okay, so see what I'm going to do. Now I have a 2.41. Okay, it is about. Okay, and so if I move the decimal point to only 1 unit, I have to change minus 4 to minus 3. So the answer itself of gamma real is about 2.41 times 10 to minus 3 per degree Celsius. Remember, alpha, beta, and gamma are always given in scientific notation. Okay? Well, my friends, thank you very much for watching our video classes. Okay? It is quite very important for us. Subscribe to our channel as well and share this video with your friends, with all those people you love, your friends, your classmates, your neighbors, your siblings, all right? And of course, send us your like. It is really very important to us, okay? I'm your teacher, Regy Safadão. Thank you very much for watching our videos. See you. Bye-bye. Have an excellent week.
That's all, folks.